Hello, everybody. Welcome back. Today we're going to take a look at the chain rule in higher dimensions and including partial derivatives. Uh, so we have our formula for the chain rule here. Um, we need to find dw dx for the things that are given here. One thing that's important to note is that um, y is completely a function of x because there's only y's and x's here, and z, the same for z. Z is only a function of x. There's no y's in this formula, and there's no z's in this formula. Um, Now, we can solve them. Oh, hang on. Okay, we can solve them for x pretty easily. Um, so 1 minus y cubed over y. And similarly with this one, this is x equals 2, or well, yeah, so it would equal z cubed minus 2 over z. Not z. Yes, z. Um, these are hard to factor, or these are hard to solve for z and y. It can be done, but it is a complete pain. So we won't be able to solve for those to find what we need to. So we need to use these in the implicit form that we're given here. Um, so first we're gonna rewrite this since we want dw dx. We just plug in an x anywhere where we see the variable p in this formula. So we get partial w partial x, and then partial x over partial x is 1, so we don't need to write that down since it's multiplied and all that. Partial w partial y, and since we discussed these are, y is a function of x, even though it's a very difficult function to find, it still is that way. So we can rewrite this as a dy dx instead of the partial. And same with this here. Partial w, partial z. I'll do a little better job at that one. Partial z, dz dx. So we have 5 things to find. We'll start out with the total derivatives that we have here. So dy dx. Like I said, we need to solve for this implicitly. So let's see. We're given y cubed plus xy equals 1. We can do the derivative of everything with respect to x. And what we get is 3y squared. Then we have to take the dy dx after that. And then we have to do a product rule here for the derivative. So we end up with, if we take the derivative of x, it's dx dx, which is 1, of course. So we end up with a y plus, then we have to take the derivative of y. So we have x dy dx. This is really just using differentials in a slightly different way. So then we can solve. Yes. And then we have this plus this equals negative y, which means that dy dx is equal to negative y, 3y squared, that is a y, plus x. And that is an x. When you have all these x's and y's, it's very important to make sure that everything is clear. And then dz, dx follows a similar way. Z cubed minus xz equals 2. And then we take the derivative of everything with respect to x. So our z cubed turns into a 3z squared dz dx. The product rule here, we take the derivative of x, it's dx dx. So this just leaves us with a minus z. And then when we do this one, it's negative x dz dx. Then of course 2 doesn't vary at all with x, so it's 0. And then the same thing here, 3x or 3z squared minus x equals dz, times dz dx equals positive z. So once again, we can solve for dz dx, and dz dx equals z 3z squared minus x. Excuse me, there. Okay, now we just need to find a couple partial derivatives which are easier. dw, or partial w partial x, we can find that directly from the formula. If we treat y and z as constants, then x squared turns into 2x, and then xy turns into y. And I'll keep doing these in a row here. dw, or partial w partial y. If we let y vary and the others stay constant, then the x squared and the z squared drop out, and the xy turns into just an x. And then finally, partial w partial z is the first two terms go to 0, and the last term turns into a 2z. Okay, now we just need to put it all together. So our dw dx, which is a total derivative, because z and y both depend on x, and since there are no other variables in the original formula besides those three, then this is total differential. So yes, we have 2x plus y. Then for our next term, we have x times negative y over 3y squared plus x. Then for our last term, we have 2z times z over 3z squared minus x. This can be rewritten as 2x plus y minus xy over 3y squared plus x plus 2z squared over 3z squared minus x. Now, like I said, we could find, theoretically, we could find a function that maps uh, these variables all together, and so we could solve for this, but in actuality, that turns out to be a huge nightmare because you have to use like cubic formulas. Um, like think the quadratic formula that finds you the roots of quadratic equations. Uh, it's that, but like way more times the effort. Um, and it gives you weird results out that wouldn't really be conducive to plugging into this. So basically, we kind of just have to leave this here. And yeah, thanks for watching.